So you're welcome back to my channel, and on this video, the continuation of our Laplace transform series, we are going to be talking about the Laplace transform of when the function of t is equal to t raised power n, and this is something like a very common type of equation in basic equations like integral equations and stuff like that. So this will be very useful. So now talking about this function here, t raised power n, there are two possible ways which we can be able to solve this. The first one will be to solve this using gamma function, and to solve this using normal integration by parts, like normal integration by parts and a little bit of logic. So I'm going to be trying my best to use the two ways. Whatever you find that is understandable for you, you can pick it on, and move on with it. So now that we have our function of t is equals to t raised power n, impute t raised power n into this, we are going to be having this is equals to, and we have our f of s here is equals to the integral from infinity to 0 of t raised power n times e raised power minus st dt. So now the easier way of solving this is by using gamma functions, which I will be doing next, instead of using integration by parts. So if I add an actual value for n, it would have been easy for me to use integration by parts. That is, if we add like t square or t cube, we would have just used the di method to solve it using integration by parts. But since we do not have an actual value for the value of n, and this is how we are able to prove this formula right here, then we it's my integration by part might be a little bit lengthy, and you need to have a little bit of logic to be able to solve it. So now, moving on to gamma functions. For those that do not know about gamma functions, first of all, the basic form of gamma function right here, we have it as we have the integral of infinity to 0 of x raised power n times e raised power minus x dx is equals to n factorial. Now this is the basic form of gamma function, and this would be actually easier if you are trying to just memorize it, and let's say a little bit of understanding. But if using using integration by parts, you'll be able to go deeply into it. But let's use this. So now this we know that this basis here is equals to n factorial, but now there is a little bit of resemblance here. The only hindrance is that this value of s that is over here. So what we just try to do over here is what we try to do here is that we use let x be equals to st. Now, for those of us that are good at use sub, like use sub in integrations, we should be able to get the edge of this. Then we differentiate the x dt. We have it as the x dt is equals to s. That we differentiate s with respect to t. It gives us s. We cross multiply. We have the x is equals to s dt. Now, the main point of this is we want to make the t the subject of the formula in order to change it to the x. So when we make the t the subject of the formula, we are going to be having the t is equals to the x over s. Do you guys understand me? So now we know that our dt is equals to the x over s. Let's take note of this as we move on. So now we impute our x is equals to st, but now we also have a value of t here. We need to change it to x. So that means this t equals to st. We change it, we make t the subject of formula, and we put t is equals to x over s. And we achieve this by dividing both sides of this by s. So we have this, we take note of this also, and now we impute this and this into this right here in order to get something that is resemblant, that resembles this. So when we move on, we are going to be having f of s to be equal to integral from 0 to infinity from 0 to infinity, that is 0 to infinity t raised power n, but our t is equals to x over s. So we just have it as x over s all raised power n. Don't do the mistake of just putting x raised power n over s. That is a very very terrible mistake. So moving on from that, we have e raised power minus st. X is equals to st, so that is minus x. So now we can see that there is being a little bit of resemblance in this and this. So then we move on to the t. The t here is equals to the x over s, so we have the x over s. So from here we can simplify it. We can break this down, put our n to both sides. We have this as integral of infinity to 0. We have x raised power n and we have our s raised power n, which is realistic because according to the rule of indices, if we have x over y raised power 2 is the same thing as x square over y square. Is a normal basic maths problem. So when we have this as e raised power minus x, then we have the x over s over s over s. So in this particular scenario, this s can multiply this s right here. We are going to have it as integral from infinity to 0. We have our x raised power n, e raised power minus x, then we have divided by x raised power n times s right here. And we know this basic law of infinity that in indices that I mentioned in the former video, that states that if we have a raised power n times a raised power n is equals to a raised power m plus n. But in this particular scenario, we are having right here, we are having s raised power n times s raised power 1. So if we multiply it, we are going to be having s raised power n plus 1. Do we all understand? So now we move on from here. Let's not forget our dx over here. Let's not forget that. So after moving on from here, we are going to be having this is equals to integral from from infinity to 0. We have x raised power n times e raised power minus x all over s raised power n plus 1 dx. So as I said earlier, s here is not a function of x, so it is a constant. It can be brought outside. That means we are going to be having 1 over s raised power n plus 1 times the integral from infinity 0 to infinity of x raised power n times e raised power minus x dx. Now for those, I can believe that you are now able to see that we have successfully found this right here. We have successfully found this gamma function right here. We are able to bring it outside. So we just use our gamma function that this here is equals to n factorial is equals to n factorial. So moving on, this will be equal to 1 over s raised power n plus 1 times n factorial, which is the same thing as n factorial over s raised power n plus 1. Now this is how we got the value of this using gamma function. So there is another way of solving this, and I'm going to be doing this in another video if you are interested of seeing the other way of solving this without using gamma function.